So IPv6 is faster than IPv4. Though the IP address is bigger, the time taken to process is not much comparatively. The reason is IPv6 header is simplified header. IPv6 header is extendable, and the neighbor discovery process provides the true host-to-host connectivity, meaning it uses a special address called link local address in order to discover neighbor. So you don't need to depend on additional protocol like ARP to discover neighbor. This link local address works on both layer 2 and layer 3. As a result, the neighbor discovery happens in just one go. Whereas in in IPv4, only when you try to communicate to someone with the help of IPv4 address, it will try to resolve the MAC address. So it is like two separate steps in discovering neighbor in IPv4. Whereas in IPv6, it's just single go. Layer 2, layer 3, link local address will be helping you to discover neighbor. Now, not only the link local address is involved, there is also routed multicast, node multicast address involved. Routed multicast address and node multicast address. These are the two different type of FF0 to colon 2, FF0 to colon 1. This is the two type of multicast address that is going to be used. Additionally, one more multicast address called node multicast address, which will also be used to learn the MAC address. So, neighbor discovery process is what our today's topic. All right, neighbor discovery and the neighbor discovery. Let me quickly on these routers, and I won't do anything, and you will see all that I have said will be shown in the debug. Now, I have not started the other router. I just started only one router. After it gets ready, I will put some debugs and show you the conversations, the discovery process. Now, debug IPv6 neighbor discovery. All right, and it's the packet needed. Debug IPv6. That itself is enough, but I'm just saying, okay, packets. All right, so I've enabled the debug on part 1. Now let me start router 2. As it is started, I'll go to router 1, and you will see a lot of information in the debug. Those informations are sufficient enough for the router to discover each other. Right, router 2 is up now. Let us give some time. I believe that IP addresses are already there. If not, it won't come. We need to fix it. Let me settle down. Let us see. Show IPv6 interface brief. Do I have IPv6 address on G3/0? Oh no, sorry. I have to put the IP addresses first. Likewise, let me check here. Show IPv6 interface brief. Oh no. Okay, no problem. I'm in router 2. Let me shut down the. Okay, it is already shut down. I'm going to configure IPv6 address on router 1's loopback first. Interface loopback 0. IPv6 address 111 colon 1111 slash 128. Look at this. I did not do anything. It has already advertised a lot of things. I'll come to this portion later. Now, next is I'll go to interface G3/0 IPv6 address ABCD colon 1/64. And this also provides a lot of information. Anyway, the other side is not ready to receive any of this information. So let us bring the router 2 up and then we'll come back here. Or I'll do one thing, I'll keep this down. I've said shutdown, okay? I've said shutdown. Let's see from the beginning. So for that, I have to bring this one up first. Interface loopback 0 IPv6 address 2222 colon 2222 slash 128. Interface G3/0. Oh no, I want to keep it down. Okay, IPv6 address ABCD colon. I'm going to give 2 here /64. Okay, we already learned that EUI 64, so I'm just removing so that you will learn who sends what clearly. When you see the debug, you will be learning who is sending what. Now, I'm going to say no shutdown on both the device. Before that, here also I would like to enable debug. Debug IPv6 neighbor discovery, debug IPv6 packets. Let's put neighbor discovery only here because packets are showing too many logs. So I don't want to have packets. On the other router, I have packets. And I have packets as well as neighbor discovery. Okay, no shutdown here. Likewise, G3/0. No shutdown. Boom, boom. Okay, let's wait. All right. Okay. What do we see here? We see a word called NA, ND, and then NS, DAD, NS. All right. So what these things are? Let us go to the other router also. Here also I see ND, and I see a special multicast address. Another special multicast address. And another thing, I can see this is coming from router 2. And now this is from router 1 itself, the local. ND, ND, ND. Okay, so we also have DAD. Now let me try to write a static route, default route IP route 0 :/0. Send the packet to ABCD : Right, so I have a static route so that I can also ping router 2. The ping I'm going to do later. Now, when I ping, even the very first packet will ping. Even though 22222, which I'm going to ping, is not directly connected. Even though it is not directly connected, there won't be any loss of packet. How? It is all because of the discovery happens before your ping. So today our focus is on the discovery. Not only neighbor discovery, the route discovery, the gateway discovery, the nearest gateway, the closest gateway. All right. So if you see here, there are 5 different types of ICMP neighbor discovery packets. NDP stands for neighbor discovery packet. Neighbor discovery uses ICMP version 6. So in order to report an error message, meaning the neighbor which was early discovered, now it's no more. For that also you need ICMP version 6. And there is a new neighbor coming in. For that also ICMP version 6 is needed. So if you see, there are different situations in which different types of neighbor come under discovery. So there are different packet types for each situation. For example, between the routers, if routers want to discover each other, so a router comes and says, hello, is there any other router online? This is what called as router solicitation or RS. Router solicitation is the one which is a kind of query process. Route advertisement is a kind of response to the query. So what happens is the all router solicitation means router solicitation packet is generated first, and a router comes in. It is now using ICMP type 133, and it generates a packet with the source address, its own link local address. Listen, this is not the address that we have configured. We have configured ABCD : 1. No, that's not going to be used. What is used? What is going to be used is the link local address of that interface. If you go to R1, show IPv6 interface brief, Here you see this is the link local address of G3/0. So with this address as the source address and show IPv6 interface brief. You need to watch this show command very carefully. Interface G3/0. Have a close look what I'm showing now. It's very important. With the source address, link local address, and the destination address needs to be a multicast address. But that multicast address should be a routed multicast address. This is node. FF02::1 is not a routed multicast address, which means these two routers are no more, they're not a router. According to IPv6, these two routers are nodes only. Why? By default, IPv6 routing is not enabled on any router. Now you see, as soon as I say IPv6 unicast routing, and you will see multicast address FF02::2 coming into picture. Where is that? The route solid station you will see. Yeah, it's not showing me, allowing me to see. Yeah. And you see there with a source of G3/. Oh, come on, let me stop this. You all. This is advertisement. I'm not interested in advertisement now before that solid station. With a source address of its own. No, this is not the one I'm looking for. Let me also go and debug again. And then let me go to the other router, and here also I'll say IPv6 unicast routing. Wait, the neighbor solid station. I'm looking for RS. Maybe after I put this, it will come. RA received, which means RS have already gone. Creating array. Okay, actually, what happens is, I want to see the FF02::2 multicast address. That is what actually used. This is node. This is that's RA. RA will use that one, but RS will use 2. FF02::2. Anyway, let me show you that on the interface now. This is what you all. This is the command that I was using some time back. That time you did not see this one. You did not see this one. As soon as I say IPv6 unicast routing, it started behaving like a router, and it sends the all router multicast address as a destination route solicitation, meaning asking for, hey, is there any router in this link? As a response to that request, the route advertisement comes. So a router is coming and saying, that is what you are seeing repeatedly. Both the routers were saying, I am array, router advertisement. So both the routers were saying, see, much more. Hmm. Creating a route advertisement. So this is trying to send to our router 2, saying that this is my link local address. Sorry, this is my link local address, and it is sending to 16. Sorry, that's Lubeck. Forget about Lubeck. Don't see Lubeck. Mm. The capture is not up to the mark. We should use Wireshark for this. Only then I can see the order in which they are sent. Let's do one thing. I'll shut down the interface G3/0 on both. Then I'm going to now enable Wireshark. All right, so I think I need to say no shutdown, no shut, no shut. Okay, here we can see a lot of capture. Okay, neighbor solicitation NS, NA, a multicast address involved. Okay, so I'm going to filter by typing ICMP version 6. Boom, that's all I want. So here are the ICMP packets from the beginning. I'm seeing only route advertisements. Let me stop the capture and come from the beginning. So here what I see is from a particular device. No, I'm not seeing FF0 to colon 2 anywhere. Route advertisement I see, but route solicitation I'm not able to see. Maybe I need to check it from, I need to generate some traffic from a host. I may need a host in between. So the routers cannot do that route advertisement. So, sorry, route solicitation. What is route solicitation? The devices, when they come in, the IPv6 device, they send a packet to this multicast address. And all those routers that has joined the group, they will respond to the node by using node multicast address F02::1. We call it as a route advertisement. That's what you are seeing repeatedly here. FF02::1. That's the response to the route solicitation. You see, this is a route advertisement. It's the response to the route solicitation. You see ICMP type 134, 134. 133 is route solicitation. Route advertisement will be always a response. And the source address, if you see, it's a link local address. You see, link FE80, all the link local address with FE80. Destination will be all node multicast. So what do they carry? They carry the IPv6 prefixes. You can see that here. It carries the ABCD : 6. That's the IPv6 prefix. It carries the prefix information. Address auto configuration, stateful or stateless. I'm going to teach you what it means. Means, if this portion is given to someone, that someone can see automatically they can form, see, the prefix. If someone gives you the network portion, you can easily provide some number as a host portion, and you can form an IP address, right? That is what called as auto address configuration, in which you have a stateful and stateless. Stateless is there is no DHCP giving any information, completely automatic. Stateful means partial information like DNS will be provided by DHCP, whereas the IP address is automatic. So all the necessary information for doing auto address configuration is given in the form of IP prefix. Also, the default gateway information, hop limit, and maximum transmission unit, all these things, see, lifetime, CMTU, maximum transmission unit, all right? And then you can also see the link local address and the hop limit of the packet, the current hop limit, and so on. So all these informations are shared as route advertisement, which is the response packet for route solicitation. A route solicitation is simply asking, is there any router? For that, the router is responding with all this information. Yeah, I am the router. See, this is the MTU that I'm using, and this is the hop limit that I'm going to have for conversations. And I can provide you IP address if you want, meaning not the IP address. I can provide you some information like IPv6 prefixes, based on which you can automatically configure an IPv6 address. It can be stateful or stateless. All these infos are shared as route advertisement called RA. After this, they want to learn the MAC address. So neighbor solicitation comes into picture. See, you can see here neighbor. So immediately after route advertisement, neighbor solicitation comes. In the neighbor solicitation, if you see, the MAC address is sent. Sorry, a MAC address is requested. It's saying I'm coming from this source, and this is my MAC address. Okay, this is my MAC address. I'm coming from this source, and listen carefully. It is sending to a multicast address, and this multicast address is the address of router 2. If you want, you can go and see there. Show IPv6 interface G3/0. You see this address? This is for router 1. It's unique. Okay, let me go to router 2 now. Show IPv6 interface G3/0. You see, for router 2 it is 2 here. For router 1 it is 1 here. So this though it is a multicast address, they are unique. And router 1 is putting, where is the neighbor solicitation? Neighbor advertisement. Okay. Neighbor solicitation. Router 1 is putting the destination address as this, which means the packet is going from router 2 to router 1. How do I know? Because I see colon 1 here in the end. Let me see the source address of this packet. Source address of this packet, neighbor solicitation. To know the MAC address, the neighbor solicitation is used. It uses ICMP version C135, and then the source address is any, and the destination is this. Source address is any, not the link local address. For neighbor solicitation, it's any, and it is sending to this multicast address. Hey, whoever is this guy is, I want your MAC address. As a response, I'm going to get a neighbor advertisement. The neighbor advertisement should come from router 2. Let me click this and see. This will be router 2. Yeah, router 2 source IP address is giving to the destination MAC address, destination link local address, and this is the link local address of router 1. If you want, you can go and check it. How they know? How do they know? They learned it via the router advertisement which came earlier. So now if you see, there will be a MAC address inside this packet. Look at this. The MAC addresses. They share the MAC address in the bracket. You can see these MAC addresses. They advertise. Now, as I said earlier, this is the link local address of router 1. Let's go and check that. Router 1. What's your link local address? You can see up here itself. Yeah. Let's compare. Link local address. Last number is 54. Yes. The previous number is FE3F. Yes. 6FF. Yes. C801. Yes. F80. You see? So, very particularly it is sending the MAC address as a response, as a unicast. We call this as what? Neighbor advertisement. So neighbor solicitation is the request of MAC address sent to a multicast address of the destination. How it knows the multicast address of the destination? In the early discussion of route advertisement, it was given to the router. So using that, the neighbor solicitation is done. The source address is going to be any, means colon colon, and destination is going to be the multicast address of the neighbor. For every neighbor, there will be a unique multicast address. I showed you in the output. So to that address only, it is sending a request for MAC address, which we call it as neighbor solicitation. Solicitation means request. As a result, advertisement comes, which is unicast, using the source address as local global unicast address example 2000 ABCD in our example ::2. Destination address is the link local address of the neighbor which sent the NS, neighbor solicitation. That's what you see here. You see, the source neighbor advertisement is coming from a global unicast address, ABCD ::2, but sent to a link local address. All right, so these are the 4 packets that helps to discover neighbor. Now, what is this redirect? Redirect is also another type of advertisement. That is to say, by chance, if the router comes to a wrong gateway, if the packet comes to a wrong gateway, for example, let me draw this and explain. In a LAN only this is possible. In a LAN, there are 2 gateways, gateway 1 and gateway 2. And unknowingly this computer is going to router 1 as a gateway, thinking that to reach Yahoo, which is another IPv6 destination, to reach Yahoo, gateway 1 will be better. But gateway 1 knows that it is not better to reach Yahoo. So gateway 1 puts the IP address of gateway 2 and send the packet to R2, gateway 2, so that the packet can be sent by using the shortest path. So the nearest gateway, very rarely this happens if you have multiple gateways, because IPv6 discovers all the destinations end to end. It knows which is the best gateway. Even if your node by mistake sent to a wrong gateway, it will be redirected automatically to the nearest gateway for the node to reach the destination. That is also another packet that is used by ICMP version 6. So if you see here, learning MAC address, learning about neighbors, link local address, learning about neighbors, global unicast address, checking whether the address that we have is unique or not by sending another packet called DAD, which I'm going to explain you in another day. Everything is ICMP version 6. So duplicate address detection is also one of the important steps in neighbor discovery, which uses ICMP version 6. So after we finish, the neighbor discovery, neighbor advertisement, neighbor solicitation, after learning MAC address, then comes this one. They advertise their global unicast address, saying this is what the address that I'm going to use from now on. Is there anyone to object? And those things are all coming in the coming classes, like as I said, DAD, duplicate address detection, and so on. So ICMP version 6 is what used in order to discover neighbor neighbor solicitation. This one we just finished. This is the last step in discovering, means learning MAC address. It is sent to a multicast address of router 1 is sending. Right. So do you have any question on this 5 different ICMP packet types?
Yeah, so Yeah. So if there is a like multiple routers, so in our case we just took two routers, but if we are multiple routers connected to
Yeah.
each other, this sort of random packet, not random, but it seems like the packets are just flowing here and there. So that will happen across all of the
Yes, see,
routers.
well, that is right. See, but not all the packets are running everywhere. Route solicitation uses a
Hmm.
router multicast address, so it will go everywhere. The
Right.
response is a node multicast, so only node can receive the packet, means whoever requested can receive the packet, not everyone. And again, neighbor
Okay.
solicitation, though it is coming from any as a source address, only a particular guy is sending it, particular device is sending it, but it puts its own source address as any, so that when a response comes, it will go to everyone, or whoever it is
Hmm.
can receive the response. So anyway, what I'm coming to say is like this, many people, many will be sending the same request to the same
Right.
multicast address, because you got many routers may be sending requests. So
Right.
instead of repeatedly um, having many packets, even if one neighbor solicitation goes, the response may become an answer for many who wants that MAC address. So here, any is the source address. The destination MAC address is the actual MAC address of the destination whose MAC address you want to learn. So this is a special multicast address which will be created using the MAC address of the local device.
Yeah. So what I understand is
No,
like so there is this
yeah, wait,
multicast
I didn't
address.
finish.
Let's say
Sorry,
if I was
sorry. And your question gave me an impression like, what is this IPv6 flooding the packet all the time here and there? No, that
yeah.
I'm trying to say no, it's not. Even though it looks like flooding, even though it looks like it is using a multicast address, but that multicast address is not meant for everyone or many. It is meant for one single person, because that multicast address belongs to that one device. Because that multicast address is
Hmm.
generated by using the MAC address. This multicast address you will not find anywhere else other than router 2, even if you have 100 routers. This portion will be unique. This portion will be
Yeah.
same, but this portion will be
Um,
unique. And if you see above,
right.
they take this number and they use it here. Exactly this number. If you go to router 1, you will see 1 there. Let me take you. So because it is going to use the MAC address, and the third bit from the left, sorry, third bit from the right, here it is. Okay, sorry, I'm confused with another number. It takes this one, but this address is not the one which I'm talking about. Anyway, this is also unique. See, for router 1, it is 1. Because
Yeah.
I said here the
Yeah.
host portion is 1. Listen, this is what actual answer is.
Right.
Whatever you give as the host portion, the global address, that is what copied in the multicast address. So there is no chance for any other router to have the same multicast. Even though the packet is sent to a multicast address,
Hmm.
it is not going to everyone. And if you see the
Hmm.
response, it is very narrowed down to a linked local address of the neighbor. So this is going to be unicast. So initially, yeah, it looks like a multicast going to all the routers, response coming to all the nodes, but still the discovery is not over. Discovery completes only when all this completes. So here, neighbor solicitation is a multicast narrowed down to one particular device. Neighbor advertisement is also unicast. So it's not like IPv6
Okay.
flooding
So
everywhere. Yeah.
yeah. So how would the router know like which MAC does it want? Like say, so RA, this is okay, fine. It sends to everybody, gets some response. But after that, like what determines that it needs to find the MAC address of something? Like say, for example, in IPv4 case, if I'm sending a ping packet, I need to know the MAC address of the host on the same segment, same VLAN. So we will try to arc for that uh, uh, host's MAC address. But here, what decides like
It
what MAC address it
learns,
wants?
no. It is not learning MAC address for one particular destination. In R, I'm picking one destination, so I learn that MAC address. And then when I pick another destination, I need to again use the ARP and learn the MAC address. This is not the case in IPv6.
Right.
In IPv6, as soon as you connect, everyone will be, every destination, everything will be discovered. So it is not one by one by one by one. So
I see. Okay.
I cannot say which destination. I will say all destination. For all destination, MAC
Right.
address will
Okay.
be
That's
learned
fine.
and kept ready. And when you ping any destination, not even a single packet will be lost.
I see. Okay. So it's like routing basically, like it's like a link
Yeah,
state routing wherein
dynamic
it
discovery,
needs to know
all the
about
links,
everybody else on the
all the
network.
link
Right.
members.
I got you.
That's right.
Okay.
Okay, so tomorrow I'm going to continue this topic again under another subtopic called DAD. Then you will get better clear picture, and then followed by we'll get into auto address configuration, which will be the third type of configuring IP address on an interface. I already explained you two ways. One is EUI64. The other one is the complete IP address. The third one I have kept it pending so that I can explain these things and take you to the third one. For third one, this one is very important. The route advertisement information is what going to support the third one. Followed by we'll do DHCP in IPv6, which will not be providing IP address, but it will be providing like DNS address and gateway. That's the role of DHCP in IPv6. In IPv6, to assign IP address, we don't use DHCP. For that, we use the auto address configuration. DHCP will be used only to provide you the gateway information and the DNS address. If Win server is there, Win server address. Right. So these things are coming later. After that, we'll be doing routing protocols. All the routing protocols: BGP, IPv6, BGP, OSP, BGP, RIP, BGP, EHRP, BGP. That's how we'll finish IPv6 class. Thanks for joining today.